friends, my name is Srinivas, known to be PS Rao. Welcome back to C level physics. In today's lecture, I would like to demonstrate some illustrations based on freely falling body. Okay, here, see first sum. A body is dropped from a tower of height h, 80 meter. Find time taken by it to reach the ground. And second question, speed just before it hitting the ground. Here value of g is 10 meters per second square. Here freely falling body, right? This is what freely falling body. Okay, so this is what reference line. This is the reference line from which body is dropped. Dropped in the sense initial velocity 0. That is u equal to 0, right? Now displacement covered s equal to minus h. Am I right? Why? Because body moving along straight line vertically below the reference line. Am I right? So s equal to minus h. Now what about acceleration? A equal to minus g. Now the question is the time taken by it to reach the ground, means time of descent, or in this case especially time of flight also. That is the time in which body remains in air. So in this case it is equal to time of descent also, right? Now see, this is what? Ground. Okay. Now time taken to reach ground means we need to find time. Here initial velocity known to be 0. Displacement covered from point of dropping to ground, that is s equal to minus h, that is equal to 80 meter. So h also known. Now a also known. So you must consider s equal to ut plus of 8 square. So we know that s equal to ut plus of 8 square. Am I right? Now s means, take sign convention, s means minus h. U means 0. 0 into t, that is 0 into t, plus of into a means minus g. Into t means time of descent. Time of descent, t equal to td. Time of descent, otherwise time of flight also in this case especially. That is h equal to minus, plus or minus minus, h 0, minus minus cancel, we left with h equal to half g td square. Am I right? That is 2h by g equal to td square. Td equal to time of descent equal to root over 2h by g. Right? This is what? Time of descent. Time of descent. So substitute here directly, that is root over 2 into h means what? H means 80 meter. H means 80 meter. That is 80. Take it in a positive sign. Why? Because already sign convention is taken. So we can substitute directly without sign convention. That is 2 into 80 by g value. What is g value? That is 10. So 0, 0 cancel. 2, 8 ja, 16 under root means 4. That is 4 seconds. 4 seconds. Right? This is what time taken by that freely dropped object to reach ground from the point of dropping. Am I right? Now coming to second, this is what first question. Second question B. Find the speed just before it hitting the ground. See, just before it hitting the ground, that is what v is unknown. Final velocity v is unknown. So you know that u, initial velocity 0, right? V is unknown. Velocity just before hitting the ground is unknown. That is how to find. How to find means here we can find final velocity just before hitting the ground in 3 ways. First of all, when body is under uniform acceleration, we came across one relation, that is displacement equal to average velocity into time. Displacement equal to average velocity, u plus v by 2 into t, right? That is s means what? Minus h. Minus h. U means what? 0. That is v is unknown. Take unknowns with positive sign on. Why? Because if it is really negative, it comes in the end on. That is, take with positive sign for unknown quantity v by 2 into t. T means td, right? That is minus h means what here? H means 80 meter. 80 which means 80 meter. That is V by 2 into TD. TD, right? TD, what is TD here? TD equal to 4 seconds. So we know that TD value also. Now time of descent 4 seconds. 4 seconds. That is 2 2 is 4. So minus 80 equal to V. V equal to minus 40 meter per second. Minus 40 meter per second. That is mod V equal to 40 meter per second downwards. See here, V comes with negative sign, means the body is moving downwards. So therefore, if you take modulus, mod V equal to 40 meter per second downwards. That is the mean. Right? Now, another model, second method. We know initial velocity, time of descent. We need to find final velocity. So take that formula, V equal to U plus AT. So second method, that is V equal to U plus A. Right? V is unknown. U means initial velocity 0. Plus A means minus G. T means time of descent. That is final velocity equal to minus GT. Plus or minus GT. Minus G means 10. TD means 4 second. That is V equal mod V equal to 40 meter per second downwards. Hitting downwards. So with that negative sign, we came to know that the body hitting the ground downwards. So on taking modulus, it becomes 40 meter per second downwards. This was second method. As far as third method is concerned, we know that V square minus U square equal to 2S also. That is V square minus U square equal to 2S. Third method. This first method, this was second method, this was third method to find final velocity just before hitting the ground. So we know that V square unknown, U means initial velocity at the level of dropping, that is 0, equal to into A means minus G. S means what? Minus H. From here to there, displacement vector is downwards from the reference level, therefore minus H. S becomes minus H. That is V square equal to minus plus 2GH. 2GH. So V equal to root over 2GH in case of freely falling body. This is what? Shortcut relation. V equal root over 2GH. Right? Here shortcut formula TD equal root over 2H by G. Here V equal root 2GH. Now on substitution, V equal to root over 2 into G means what? 10 from data, 10 meter per second square into height. What is height? From which body is dropped? That is 80 meter. 80 meter. Am I right? So V becomes equal to, see here, 2 into 10, 20 into 80. That is 1600 under root. That is 40 meter per second square. It is in fact plus or minus. Root takes either plus or minus, but in our sum, as body moving downwards, definitely this is negative. Negative. On taking modulus, it becomes 40 meter per second. 40 meter per second downwards. Okay. So that's how one can find velocity just before hitting, either by one of these formulas. Okay. Right? This time, a freely falling body travels a dash of total distance in 5th second, which is last second. See, total time of journey, how many seconds? 5 seconds. Now 5th second. A freely falling body travels a dash of total distance in 5th second. Distance covered by 5th second divided by distance covered in total 5 seconds. That is the question. So, question is S5 by S of 5. That is the question. S5, S suffix 5 means the distance covered in especially 5th second divided by distance covered in total 5 seconds. S of 5 means distance covered in total 5 seconds. That is the question. So how to solve this sum? See here. This is what freely falling body like that. Right? Freely falling body. Okay. So this is what reference line. So this is what freely falling body. initial velocity is 0 for freely falling body, right? A equal to minus g, right? A equal to minus g. Now we know that S equal to ut plus of h square. We know that S equal to ut plus of at square, right? This is what distance covered in t seconds, that is S of t. In fact, S of t means distance or displacement covered in total t seconds. If t is replaced by n, if total time of journey is n seconds, then same can be replaced by like that. See, S of n equal to un plus of a n square. See, t is replaced by n. Say t equal to n, right? For a freely falling body, same can be written as u equal to 0. So therefore, S of n equal to 0, freely falling body, u equal to 0 into n plus of and a means minus g into n square. So S of n equal to minus of g n square. This is what number 1, right? So displacement or distance covered in total n seconds minus of g n square, right? S becomes negative. Why? Because body is moving along a vertical line below the reference line. That's why S is negative, right? Similarly, we have one more relation, that is distance or displacement covered in nth second, particular nth second, not in n seconds, nth second. So S suffix n, we know that S suffix n equal to u plus a by 2 into 2n minus 1. Am I right? S suffix n equal to u plus a by 2 into 2n minus 1, where u, initial velocity 0, that is S suffix n equal to 0 plus a means minus g by 2 into 2n minus 1, right? That is S suffix n equal to minus g by 2 into 2n minus 1. This is what number 2. Now the question is S suffix 5 by S of 5, that is S suffix n by S of n. Say n equal to 5 seconds. Here in our sum, n equal to 5 seconds, total time of journey 5 seconds. So obviously last second also 5th second, as total time of journey is in 5 seconds, last second is nothing but 5th second. Now the question is S suffix 5 by S of 5, right? S suffix 5 by S of 5, that is, we know that S suffix n by S of n equal S suffix n means minus g by 2 into 2n minus 1 minus g by 2 into 2n minus 1 divided by S of n equal to minus g by 2 into n square minus g by 2 into n square. So minus g by 2 cancel with each other. We left with S suffix n by S of n equal to 2n minus 1 by n square. So S suffix n by S of n equal to 2n minus 1 by n square. This is the shortcut relation. S suffix n by S of n equal to 2n minus 1 by n square. Now n is replaced by 5, that is S suffix 5 by S of 5 equal to 2 into 5 minus 1 by 5 square. 5 square. Alright, that is 2 5 ja 10. 10 minus 1 9. 9 by 25. 5 square means 25. Right. Fractions. Suppose if it is multiplied by 100 on both sides, then S suffix 5 by S of 5 percentage equal to 9 by 25 into 100. 9 by 25 into 100. That is 100 by 25 means 4. 4 9 ja 36 percentage. 36 percentage. What is the reference here? Means distance covered in 5th second divided by distance covered in total 5 seconds is equal to 36 percentage. 36 percentage. Means if this is the 5th second, this is what total 4 seconds. 4 seconds. See, total 5 seconds. From here to there, time elapsation, that is 4 seconds. This is what distance covered in 5th second, means especially in 1 second only. 5th second in the sense 1 second only. So from data, from inference, this is what total distance covered in 5th second equal to 36% of total distance. If total distance is S, right? Out of S, 36% of total distance only covered in 5th second. That is the inference from that relation. Okay. So in first 4 seconds, what is the distance covered means remaining percentage. That is total percentage 100. Here 36 over remaining means 64. So 64% of total distance is covered in first 4 seconds. Especially 36% of total distance is covered in 5th second, last 1 second. Right? That is the meaning. Okay. Here, the ratio of time taken by freely falling body to cover first meter, second meter and third meter, etc. Alright? Here, see, this is what reference line from which one body is dropped like that. So this is the path followed by freely falling body, right? So as it is freely falling body, U becomes 0, right? Now the total path is divided into equal segments. First meter, second meter, like that. See, this is what first meter. This is what second meter. First meter. This is what from here to there second meter. From here to there third meter. Okay, from here to there fourth meter, like. See, this is what fourth meter, like. Right? See, body is going to move vertically downwards as shown. Now the total path length is divided into equal segments, each of 1 meter. First meter, second meter, third meter, fourth meter, like that. Of course, of equal sizes only. See, first, second, third, fourth, etc. Total path is divided into equal segments as shown. Now we need to find the ratio of time taken to cover respect to meters here. Right? To cover first meter, to cover second meter, to cover third meter, etc. We need to find the ratio of time taken to cover respect to meters. That's what given question, right? Now we know that in case of freely falling body, S equal to ut plus half h square. S equal to ut plus half h square. Usual form. S means here minus h, for example, u 0. So 0 into t plus half into a means minus g. A means minus g. Why? Because g is always vertically downwards. Here t square. Right? So minus cancel. H equal to 0 plus or minus half g t square. Half g t square. That is 2h by g equal to t square. T equal to root 2h by g. This is the required relation. Right? In case of freely falling body, time taken to cover certain distance is given by root over 2 into height through which body moves divided by g. That is the relation. Am I right? Now what is the time taken to cover first meter? That is t1 equal to root over 2 into 1 by g. H means 1 meter only. See, this is what t1. Time taken to cover first meter. That is t1 equal to root over h means first meter. That is 1 meter. 1 by g. Now t2. How to get t2? Time taken to cover second meter. Means that is from here to there. From here to there. This is the distance through which body covers second meter. Now, what is the time elapsed for that covering? Means t equal to, how to get t? Means time taken to cover total 2 meters minus time taken to cover first meter. See, time taken to cover total 2 meters from here to there minus time taken to cover from here to there. That is the total time taken to cover 2 meters minus total time taken to cover first meter. That is root over same can be written as, that is t of 2 meters minus t of 1 meter. What is t of 2? Time taken to cover first 2 meters. 1 meter, 1 meter. Right? Time taken to cover first 2 meters minus time taken to cover first meter. That is t of 2 minus t of 1. Now what is t of 2 means? Substitute here. T means root over 2 into h means what? 2 meters. 1 meter plus 1 meter. That is 2 into 2. 2 into 2 by g minus again t of 1 means h is 1. That is root over 2 into h means 1 meter. T of 1 means first meter. Time taken to cover first meter. That is 1 meter. 2 into 1 by g. That is t2. Root 2 by g is common. Root 2 by g is common. That is root 2 minus 1. Alright? This is what t2. T2. This is what t1. Right? Now how to get t3? T3. Time taken to cover especially third meter. See, this is what third meter. Right? Time taken to cover third meter. How to get this time taken to cover third meter means the total time taken to cover 3 meters minus total time taken to cover 2 meters. Right? From here to there 3 meters. From here to there 2 meters. So time to cover 3 meters minus time to cover 2 meters. That is t of 3 minus t of 2. T of 3 minus t of 2. Now, see, this is the formula. That is t of 3 means replace h by 3 meters. That is root over 2 into h. H means 3 meters by g minus again 2 of 2 means replace h by 2 meters. That is 2 h by g. H means 2 by g. Again root 2 by g is common. Root 2 by g is common. That is root 3 minus root 2. Right? Similarly, T4. Time taken to cover fourth meter. Time to cover especially fourth meter is given by total time taken to cover 4 meters. First 4 meters minus time taken to cover first 3 meters. You will get especially time to cover fourth meter. That is T suffix 4. That is root 2h by g. Once again, root over 2h means 4 by g minus root over 2h means 3 meters by g. Here again root 2 by g is common. Here root 4 minus root 3. Right? So likewise. Suppose up to so on t suffix n equal to root 2 by g of root n minus root n minus 1. 4 minus 3. Here 3 minus 2. Therefore root n minus root n minus 1. Now what is the common ratio here? Root 2 by g is common in every time. That is root 2 by g, root 2 by g, root 2 by g cancel in the ratio. We left with and taking t1 is to t2 is to t3 is to up to tn equal to here t1 means root 2 by g. Root 2 by g. Same can be written as root 2 by g. Root 2 by g is common into root 1 minus root 0. Root 0. See? Root 2 by g is common. We left with root 1. Minus nothing is there means root 0. Why? Because n minus 1. Therefore root 1 minus root 1 minus 1. That is root 0. So common term. Root 2 by g common. Here also root 2 by g common. Here also root 2 by g common. Here also root 2 by g common. That is cancel. Take remaining terms. That is root 1 minus root 0. Root 1 minus root 0 is to here root 2 by g is gone. We left with root 2 minus root 1 here. Root 2 minus root 1. Right? That is root 2 minus root 1 is to next here. Root 2 by g gone. We left with the root 3 minus root 2. That is root 3 minus root 2 is 2. Here root 2 by g gone here. We left with root 4 minus root 3. Root 4 minus root 3 up to root n. See last term root 2 by g gone. We left with root n minus root n minus root n minus 1. Root n minus 1. That is the answer. Okay. Next sum here. Two balls are dropped from the same height at two different places A and B, where the acceleration due to gravities are G and G. The body at B takes t seconds less to reach the ground and strikes the ground with a velocity greater than at A by V meter per second. Then the value of V by T is. See from data, this is the reference line from which body is dropped at place A. This is what place A. It is place B, for example. See this is what ground. Now at place A, body is dropped like that, right? Now what about initial velocity u0? Here also dropped one more body like that. U equal to 0 here also, right? So in both cases, at both places, two balls are dropped through same height, from the same height as shown. See, this is the height from which body is dropped. Here also, through the same height body is dropped, right? So in both cases, at both places, two balls are dropped from the same height, right? Here also height is h, here also height is h, right? But here at place A, the time taken to reach ground is t1, for example. T1 equal to root 2h by g. Here t2 equal to root 2h by gb. Here ga. At place A, what is the acceleration due to gravity? Ga. So that's why root 2h by ga. At place B, what is the acceleration due to gravity? Gb. That is root 2h by g. Now at place A, with what velocity it hits the ground means that is V A. Final velocity just before hitting equal V equal to root 2gh. Root 2gh. 2gah. Here, what is the velocity with which it strikes the ground means VB equal to root 2gh. That is GBH, right? How to know means, how do you know means, now itself we came across velocity on reaching the ground is equal to root 2gh, right? In previous sum, that is VA equal to root 2gh, here VB equal to root 2gh, right? Like that. But from data, time taken to hit the ground at B is t seconds less than at place A. That is TB equal to, that is otherwise T2 equal to T1 minus T, right? What is the time taken at place A to hit the ground means that is T2, which is equal to t seconds less than at place A. That is T1 minus T, right? That is T1 minus T. What is T2? T2 means root 2h by GB, right? GB. Okay. That equal to T1 means root 2h by GA. Root 2h by GA minus T. Now what is T? T equal to T. Carry this T to LHS, that is root 2h by root 2h is common here. That is 1 by root GA minus 1 by root GB. 1 by root G, right? Right. This is what number 1. Now as far as velocities are concerned, VB is somewhat more than VA. See from data, when body is dropped at place B, acquires a velocity V meter per second more than at acquired at velocity place A. That is VB. VB equal to VA plus V, right? Velocity at B on striking the ground is equal to velocity at A on striking the ground plus V. See, this is what additional velocity acquired by body which is released at place B. By what amount means V amount, right? It acquires additional velocity. Why? Because here GA is not equal to GB. GA is not equal to GB. In fact, GB is greater than GA, right? Why? Because as it takes lesser time to cover the same distance and acquiring more and more velocity than at place A, therefore we came to know that G at B is greater than G at A, right? That makes the difference to have different times and different velocities, right? VB equal to VA plus V. That is, what is VB here? VB means root 2GH. Root 2GBH. Equal, what is VA? That is root 2GAH. That is root 2GAH plus V. Now on make it subject V, that is V equal to root over 2G, root over 2H is common, that is root GB minus root GA. Right? This is number 2. Now the question is to find V by T. Now V, what is V here? Additional velocity acquired by freely falling body which is dropped at place B. That is what additional velocity acquired. V met per second. That V by T is question mark. V by T means we have V value, we have T value. Now take 2 by 1. 2 by 1 implies that is 2 by 1. 2 by 1 implies that is V by T, LHS by LHS. V by T equal to here root 2H by root 2H into root GB minus root GA divided by, here see what is RHS? Root 2H of 1 by root GA minus 1 by root G, right? So LHS by LHS equal to RHS by RHS. That's what written on the board. Now on extending, see here, V by T is equal to root 2H cancel. Now here root GB minus root GA whole into, take LCM here. What is LCM? That is LCM root GA GB, right? Root GA GB. Root GA into root GB. Now 1 into root GB, root GB minus 1 into root GA, that is root GA, right? Now this term goes to numerator, that is this term by this term cancel with each other. That equal to 1 by root GA GB means root over GA GB. Root over GA GB. This is what V by T. So additional velocity acquired divided by lesser time to reach ground at place B is equal to root over product of acceleration due to gravity set place A and place B. That is V by T equal to root over GA GB. Okay. Finally, one more numerical here. See, a vertical disc has 3 grooves directed along chords AB, AC and A. See, the 3 bodies begin to slide down the respective grooves from A simultaneously. If AB is greater than AC is greater than AD, the respective time intervals to reach bottoms of the respective grooves T1, T2 and T3 are. See, this is what one circle, vertical disc, in fact, vertical disc on which 3 grooves are marked as shown. See, AB is one groove, AC is one groove, AD is one more groove. Likewise, here 3 grooves are marked on the surface of the vertical disc of radius R and diameter 2R. See, with center O. This is what radius R. This is also radius R. Now, what is the total diameter R plus R? That is 2R. O is the center. A is the highest point. Right? Now, AB, AC, AD are respective grooves marked on the surface of the vertical disc as shown. Now, here 3 balls are released from highest point such that to slide in respective grooves from A to B. Time taken is T1. From A to C, time taken is T2 seconds. From A to D, time taken is T3 seconds. Right? Right? Now, the question is, what is the relation between among T1, T2 and T3? That is the question. Right? Now see, from data AB is greater than AC is greater than AD. See, the groove length AB is greater than groove length AC, which is greater than groove length AD. Right? That is the data. Right? Now the question is to find the relation between T1, T2 and T3. Right? Now I am highlighting this right angle triangle here. See, right angle triangle. Now this is what A, right? This is what B. Here it is 90 degrees. Now what is this vertical displacement covered by this ball while going from A to B means R plus R. See, this is the vertical displacement covered. This is the vertical displacement covered by a ball which slides along chord AB, right? R plus R. This is the vertical displacement. So this is what 2R. 2R. Right? Now say this is what angle theta. Now what is this side hypotenuse? Definitely 2R cos theta. 2R cos theta. Hypotenuse. Right? 2R cos theta. Now here ball is released to slide from A to B. Right? Okay. Now as far as G is concerned, acceleration due to gravity. One more diagram likewise. One more diagram. See, this is what G. Always acting vertically downwards. Here the same angle theta. Now what is the component along the hypotenuse? That is G cos theta. So here it is G cos theta. G cos theta. So component along hypotenuse for G is G cos theta. For what displacement is 2R cos theta. Now go with S equal to ut plus half a square. We know that S equal to ut plus half a square, right? Okay. Of course, I considered the ball which slides from in the groove from A to B1, right? That is S equal to ut plus half a square. What is S here? Along the hypotenuse, otherwise along the chord AB. What is the displacement? Of course, along vertical means 2R. See, one ball is released from A such that to move along chord AB. For the, especially that for that ball, what is the vertical displacement chord means 2R. Now, what is its component along chord length means that is 2R cos theta. So, minus 2R cos theta. On taking sign convention, minus 2R cos theta. Why? Because 2R is negative. So, this is also negative as per sign convention. As per sign convention, minus 2R cos theta. That is, U is 0 at A. At the point of dropping the ball, each ball, what is the initial velocity? That is U equal to 0. U equal to 0 into T plus half into A means what? Along the chord length, A means G cos theta. And taking sign convention, minus G cos theta. Minus G cos theta into T square. Right? That is plus or minus minus. Here it is 0. Plus or minus minus. Here also minus. Cancel. Both negatives cancel. We left with cos theta also cancel. We left with 2 4R equal to G T square. G T square. That is T equal to 2 root R by G. This is the relation. This is the relation. Right? What is the ultimate expression for time to travel from A to B or A to C or A to D, whatever it is? That equal 2 into root over R by G. R means radius, G means acceleration due to gravity at that place. See here, R means radius of the disc, that is constant. G means acceleration due to gravity, that is also constant at that given place. Right? Here 2 also constant. If you consider second ball which slides along the chord AC also, you will get same relation. Even for third ball which slides along chord AD also, same expression. Right? No variable in this expression. 2 constant, radius constant, G constant. Ultimately, time is constant. That is T1 equal to T2 equal to T3. T1 equal to T2 equal to T3. Of course, there is some difference in chord lengths. AB is greater than chord length, AB is greater than, otherwise groove length or chord length, AB is greater than, AC is greater than AD. But still, but still all the three balls reach their respective destinies B, C, D while sliding respect to grooves AB, AC, AD is same. Time taken is same, but grooves lengths are different, but still time taken are same. So time taken for that ball along AB is equal to time taken for that ball along AC is equal to time taken for that third ball to move from A to D in third chord also, third groove also same, right? No difference. No difference at all. Suppose if you are given like that, see, this is what one disc of radius r equal to 10 meter, right? Here one string is stretched between A and B like that, between A and B. So AB is the string stretched. This is one string stretched between A and B on the vertical circle of radius or that is 10 meters. Now one bead is released from A such that to move along AB. Now find the time taken by the bead to reach B from A. Means now T equal root over 2 into root over R by G. This is the shortcut formula, right? This is what time taken by the bead to slide down along AB. Here also at A, what is the velocity? U0. U equal 0. Now I am taking like this, S equal minus 2R cos theta, A equal minus G cos theta. We'll get one shortcut relation. T equal root 2 into root over R by G. That is 2 into root over R means what? Radius of the, see, this is the radius of the disc, that is 10 meter by G also 10 for example. 10 meter per second square. So 10 by 10 means cancel. That is 2 seconds. 2 seconds. This is what? One integer question. Okay, that's how one can find time taken by one bead when it slides down the string fixed between A and B on a vertical cycle action. Okay friends, this I conclude. I am signing off. Thank you.